Okay, Algebra 8. We are doing section 3-4. We're introducing functions today. So we have some new vocabulary that I want to focus on, and we have the word relation, domain, range, and then function. And I know that sometimes just the vocabulary alone can be a little bit intimidating. So let's just talk about it. We're simplifying this. A relation is a set of ordered pairs. So it means more than one. So it's like 3, 4, couple. The domain of a relation of a set of ordered pairs is the set of all the first components of the ordered pairs. So just the 1, just the 3, just the 5. Okay, this is usually the X. The range is the second components. So if you're looking at that same relation, the 2 is the second one, the 4 is the second one, the 6 is the second one, and this is generally the Y. Okay? So the first type of problems, they want you just to write the domain and the range. So the domain are the X's. So the domain, and you use these little brackets, -1, -2, and -3. The range are the Y's, so it would be 1, 3, and 5. Number 2, it doesn't matter that they give you letters, it's still the first component. This would kind of still be your X. You're thinking about these X, Y, X, Y. The domain is A, B, C. The range is 1, 2, 3. Okay? So now we're going to talk about how a relation makes a function. And the reason is because not every relation is a function. So the rule with a function is that each element of the domain corresponds exactly to one element of the range. And I know that sounds really confusing. The way that I like to think about it is that each X has only one Y. Okay? And the reason that this is because this is a function. If I put a 1 in for X, I'm going to get 1 plus 3, so my Y is going to be a 4. If I put a 2 in, I'd get 2 plus 3, and I'm going to get a 5. If I put a 3 in, I'm going to get 3 plus 3, and I'm going to get a 6. Each X has only one Y. If I put a 1, I'm not going to get a 5, or I'm not going to get a 6. So when we look at these are called mapping diagrams. When I look at them, a function, when I put in an A, I get a D. When I put in a B, I get a D, and that's okay. I put in a C, and I get an E. So this is okay. A only has one partner. But when we go over to the not a function, in this particular one, when you put in C, it gave you 2 different responses. Okay? 2 different, if I can write correctly, 2 different ranges, or Y's. So the reason why is that C has 2 partners. And that is not okay. If I made a mapping diagram to show you guys these, I would put the 1, the 2, and the 3 in for the X, and the 4, the 5, the 6 in for the Y. And I would just draw these lines. Each one only has one answer. Now, sometimes it does happen where we put in different values and we do get the same answer. And a perfect example of that would be if I had y equals x squared. I'm going to show you why here. If you put a negative 2 in, a negative 1 in, a positive 1, a positive 2, you get negative 2 squared, negative 1 squared, 1 squared, and 2 squared. Negative 2 squared gives you 4. Negative 1 squared gives you 1. 1 squared gives you 1, and 2 squared gives you 4. So if I were to make a mapping diagram of this, I would have negative 2, negative 1, 1, 2. And I would have, you only have to put the 4 and the 1 over here. You don't repeat them when you do a mapping diagram. So negative 2 went to a 4, negative 1 went to a 1, 1 went to a 1, and 2 went to a 4. So this is okay. They can share a y, but the thing is that in all my inputs, I didn't put a negative 2 in, and it didn't give me 2 different answers. I didn't put a 2 in, and it gave me 2 different answers. So that is the big tell. When you put a number in and it gives you 2 different answers, that doesn't work for a function. It doesn't happen. So when we look at our mapping diagrams, can you tell if it's a function? Well, these all go to the same answer. That's okay. It happens, not very often, but it happens. And so, yes. And how you would support this is you would say because each x, or domain, only has one range value, and that's a y. So on number 4, this one is not, because A goes to D and E. So no, not a function, because A goes to D and E. The domain has 2 ranges, which is not okay. You can't have 2 ranges for one domain. So that's how you can tell if you have a mapping diagram. The next way is if we have a graph, okay? And if we have a graph, they have this thing called the vertical line test. So this VTL, vertical line test. And this is probably the easiest way to tell if a function is a relation is a function. Because if you have a graph of it, you can do this thing called the vertical line test. And what that means is that you kind of pretend to draw these vertical lines across your whole entire graph. If it crosses the graph twice, if one line crosses twice, it fails. Okay? So you can put that here. If one line crosses the graph twice, it fails the vertical line test. So number 1, it passes. Is it a function? Yes. Number 2, and you can picture this, it passes. Number 3, though, if I draw a line, it crosses here and here. Does this one pass? No. Number 4, you can, even though it's a squiggly line, I can draw a million vertical lines. Does it pass? Yes. But number 5, though, you can look right here. It's not the only place. Look at this one, it crosses 3 times. So this one is a no. Then number 6, even though it's squiggly, I don't see any spots where it would fail that vertical line test. So it would be a function. So that's the vertical line test. If it crosses the vertical line twice or more, it's not a function. And I apologize, this definitely turned out way smaller than I wanted it to, but I'm going to read it to you. So it says, is it a function from a graph? You don't want an x to repeat. It needs to pass the vertical line test. So this is a function, this isn't a function. So you can see a circle here would fail. This would be like y is 2, x is positive 6, negative 2. So from a table, one thing that you're looking for is that x does not repeat. That is a function. If x repeats, it's like this one right here, a would not repeat, b would not repeat, c does not repeat. But my x's, it would be like d, d, e. Because if I took this and I made a little table of information here, I would have a, b, c, and this would be d, d, e. So we have that repeating value in the y. If x is repeated, not a function. Oh, they put two different ones. I'm just trying to read this one. Well, maybe just kind of ignore that one. That one's kind of tough to read. Oh, sorry, this would be 1, 2, 3. Oh, I missed one here. That's why. That would make more sense. There should be 2 A's. And A goes with D, B goes with D. A also goes with E. That's where I kind of confused that one. Sorry. Go back to this. A goes with D, A goes with E. And that's where it mistakes, because you can't have the same value go two different. So if the x repeats, you have to check those y values. Okay. So your assignment, oh, we've got one last little part, sorry. And this kind of relates back to what we've been doing. So it says we're given a function rule, which is just this equation. We have to choose the convenient y values. Those are your inputs, or x values, sorry. And then you're gonna get out the y values and then you're gonna graph them. Most of the time, it doesn't really matter what values you put in. In these ones, we'd go -2 to 2. So if they don't give you x values, you're just going to do that. So this one's done for us. They put in the x, they solved it, they get the y, they graph their points. This is not new to you guys. So we're gonna do this one together really quick. -2 minus 1, -1 minus 1, 0 minus 1, 1 minus 1, 2 minus 1. -2 minus 1 is 3, -1 minus 1 is -2, 0 minus 1 is -1, 1 minus 1 is 0, 2 minus 1 is 1, and we're going to go graph them. -2, -3, -1, -2, 0, -1, 1, 0, and 2, 1. So there is our relation or a function. And then, would this pass a vertical line test? Does every x have its own y? So is this a function? Yes. Okay, same thing here. We have 2 times -2 plus 1, 2 times -1 plus 1, 2 times 0 plus 1, 2 times 1 plus 1, 2 times 2 plus 1. 2 times -2 is -4 plus 1, so that'll give you a -3. 2 times -1 is -2 plus 1 would be -1. 2 times 0, 0 plus 1 is 1. 2 times 2, or 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. Go here, -2, -3, -1, -1, 0, 1, 1, 3, and 2, 5. Again, we just graphed a line, and most lines are functions. Okay, and so you can see on the next page you have your worksheet, and that is all for today.